Hello. A key notion in flat earth beliefs is that water always finds its level. If this is true, it must mean that bodies of water will have surfaces that are parallel to the plane of the flat earth, and therefore the Atlantic Ocean must be flat. This is something we can investigate. Let's construct an experiment to do just that. We start by taking measurements of the position of the Sun from a number of places which meet the following criteria. 1. They experience solar noon at the same instance. This is something that happens when two places fall on the same line of longitude. 2. That they are next to the Atlantic Ocean or some freely connected sea. For this analysis we choose Plymouth in the UK, Malaga in Spain and Abidjan in Côte d'Ivoire. What we are going to do is measure the elevation of the Sun at solar noon on each of the solstices and one of the equinoxes. In this execution of the experiment, we're going to get the measurements from the SunCalc website on the understanding that we could validate those measurements in reality. You can see how I extract such data from SunCalc in a previous video. Here is the data I extracted. You can see that the places are up to a few tens of meters above sea level and all close to the 4-degree longitude line. We'll assume that these differences will not significantly impact the analysis. Because the azimuth measurements line up along the longitudinal line, we can take these elevation measurements and map them onto a two-dimensional diagram, which we will construct with a ruler and a protractor. We start by drawing a straight line to represent our flat Atlantic. Now, we need to put the places from which we took the measurements onto this line. Assuming that the elevation measurements create a straight line from the observer to the Sun, we can use triangulation as a way to construct a scale diagram that incorporates the three chosen places and the Sun. We choose two of the places and put them some distance apart. We then use the elevation measurements for December to locate the Sun relative to the two places. Once we've placed the Sun on the diagram, we can then use the December elevation measurements for the third place to triangulate back from the Sun to the flat Atlantic to locate the third place relative to the Sun and the other two places. Now we have a scale drawing of the situation in December, and we can measure the length of the line segments between each of the objects as shown. In terms of the distances to the Sun, we see that the distance to the Sun from each place is radically different, meaning that the apparent size of the Sun at each place on this date is predicted to be measurably different. No such difference has ever been reported, as far as I know. If we can get the actual value of one of these line segments, we can use that to predict what the other values should be. According to sources on the internet, the distance from Plymouth to Malaga is 1,517 kilometres. Since that distance in the diagram is 10 centimetres, we can calculate the scale factor for measurements on the diagram, which is 151.7. Knowing this, we can then predict the distance from Malaga to Abidjan from the diagram, and that will be the value 986.5 kilometres. Returning to our internet source, we find that the distance from Malaga to Abidjan is, in fact, 3,477 kilometres. This is hugely different from the value we predicted. This doesn't look good for the idea of a flat Atlantic, but let's use the other measurements we collected and see if they can help clarify the situation. Let's add the March measurements to the diagram to locate the Sun on that day. The Sun will be where all three measurements intersect. Problem is, there is no such place. We find a similar situation when we add in the measurements from June. So, to summarise, we were unable to correctly predict a known distance from the scale diagram. We have predicted noticeable differences in the size of the Sun in December at each place. No such measurements have ever been made. We could not make any prediction on the whereabouts of the Sun for the dates in March or June when we assumed the December diagram was a true representation of the Atlantic Ocean.